What's up guys, Kieran McAvoy here from A Clever Chimp, and on this channel we talk, learn and discuss about maths, physics and all things engineering. This video is part of our guide to engineering maths, and today we're going to be talking about the inverse of a 2x2 matrix, and we'll bump into the identity matrix as well. But we're not going to just talk about the inverse of a 2x2 matrix or just tell you how to do it. We're going to find the inverse of a 2x2 matrix and understand why it is we have to do this, muddling around with the matrix. All of that is coming right up. So what is the inverse of a matrix, first of all? Well, it's kind of the, you can understand it as the same sort of thing as in normal algebra. Like if you just had a number, its inverse is 1 over that. So if you were to multiply them together, you would just get the number 1. So that's pretty much what it is in matrix algebra. Essentially, it's just that, you're not necessarily doing 1 over it. It's not really like that. But in terms of what it means in just matrix algebra, it is like that basically. So it's not just a matter of just putting a massive 1 and then plunking the matrix in the denominator. That's not what it's about. What it is if we can find a way that had to have a matrix, just any matrix, and then multiply it by another matrix that gives us what's called the identity matrix, and that identity matrix consists of 1, 0, 0, 1. That essentially means that if we were to multiply that identity matrix to any other matrix, all it does is it spits out that matrix. It's essentially like multiplying the thing by 1. You're actually reproducing it, to be fair, but you are essentially just reproducing it, so you'll just end up having the same matrix that you've multiplied by the identity matrix. So in essence, that's a great place to start. Why don't we set up an equation where we have two 2x2 matrices, one that we're going to be having as just the generic one, and the other one that we're going to be looking to find what its elements are, to make sure that when we multiply them two together, we get the identity matrix. So let's set this up. Now it's going to be sort of algebra heavy, but we're going to talk through it, all right? Because we'll just go through it. We'll go slowly, or just get excited about it and just rush through it. No, we're not going to do that. But we are going to. We'll go through it. We'll go through it. Right. So let's choose our generic matrix, and we're going to do this in the generic sort of 2x2 fashion, where we call the elements A, B, C, and D, and we have that as our generic 2x2 matrix. Okay, and the inverse that we're going to be multiplying, post multiplying it by, is A dash, B dash, C dash, and D dash. Okay, so we'll just do that so that we can actually tell the difference between the two. Okay, and that by definition equals 1, 0, 0, 1, and essentially, I like to think that this is a very kind of the way that a lot of maths is set up, is the fact that they sort of, and this is actually a lot of the way that some maths has been discovered, is basically by thinking that it's going to happen, let's just set it up. Let's just assume that it is. We've just set up an equation there that we haven't actually known whether it exists. We don't know whether that even exists at this point. That could be completely false for all we know. But we're setting it up and we're testing it. And truthfully, I think there's nothing wrong with that. I think it's a great way to actually sort of, work with math. So let's crack on. So through matrix multiplication, we have A times A dash plus b times c dash as the first element of our new 2 by 2 matrix. So a times a dash plus b times c dash plus b times c dash. That's going to be the first element of our new 2 by 2 matrix. So once again, we'll go row, second column, first row, second column. So a times b dash, a times b dash, plus b times d dash, plus b times d dash. And we'll do the second row, first column, c a dash plus d c dash, c a dash plus d c dash. And then second row, second column, c b dash plus d d dash. And that is our new that's our multiplied 2 by 2 matrix, and that equals 1 0 0 1. Okay. Now, the part that I did now is that I kind of noticed that, well, we essentially, you know, element-wise, we can match up these. You know, we know that, you know, from matrix algebra, that basically this matrix here, the elements in this, considering that they're both the same size, we've got 2 by 2 equals to 2 by 2. So that means from matrix algebra that basically this element here equals this element here equals this element, like the first row, second column here, you know, and so on, right? So let's set up 4 simultaneous equations. So we have a dash plus, and there's no b dash in here, so that's 0 b dash plus b dash, b c dash, and then plus 0 d dash. There's no d dash in that equation there, so 0 d dash, and that equals 1. Okay, so you get the idea. I'm going to skip through this next little bit and you'll just see the resulting thing. So you'll know that's what I'm doing. I'm just basically doing that is equal to that, that is equal to that. But I'm making sure that I keep all of the variables involved, because you know what we're going to do? We're going to do some Gaussian elimination on this. You know, you can just feel it. Okay, so there are equations there. So we've got everything in terms of the 4 unknowns, the a dash, b dash, c dash, d dash, right? And any that have, you know, that aren't involved have a 0 on it, and that's great because that means that it'll fill out our matrix beautifully, right? So we've got it in our augmented matrix form now, and what I need to do now is we need to make sure that we want to get, so the one we're happy with that value a being up there, that's absolutely fine, but we want all of these down here to be 0 because we need this to be an upper triangular matrix here. This needs to be an upper triangular matrix, so we need to get rid of this c. Okay, so what we're going to do is we're going to say that, like following the algorithm that I talked about in the Gaussian elimination video, we're going to say 3. I'll do this in different color actually. I'll do it in different color so that we can follow what's going on. So row 3 is going to go to row 3 minus, and we've got a and c here. So we're going to have to minus c over a times by row 1, right? So that'll mean then for that element, that's going to be c for that element, c minus c over a times by a, which will just cancel out with the a's and we'll just be left with c, so it'll be c minus c, and that will get us rid of that. So that'll be 0 there, okay? So what we're going to do is we'll just write that out now. So our new row, our new third row is going to be equal to 0, 0, because we've got a 0 up here. So that's great, that's nice and helpful, because we've got 3 minus c over a times 0, so that's just going to be 0 there, so that's going to be 0, 0. Now, we have 3, so this is just going to be equal to d minus c over a times by b here. So that's our new element there. That's our new element. Okay, so that's d minus C over A times B. And we have 0 for the fourth element because it's 0 minus some C over A times 0, so that's just 0. But remembering, again, the other side. So we need to do 0 minus C over A times row 1, which is, so we'll just put the 0 in there, divider, and then we've got 0 minus C over A. So 0 minus C over A times 1. So minus C over A, it's just going to be minus C over A, right? So 0 minus C over A, which is just going to be minus C over A. And that is our new row. Boom. Crushed it. So, that's our new row. We've got rid of that element there. The next one to get rid of is this element here. So actually, what we can do, before we write out the new matrix, we can just go ahead and do that straight away, because it doesn't have, we can use this row here. It doesn't have anything to do with the other rows that we've just messed around with. Okay, so what we'll do is we'll just do that straight away now. So let's just make a little bit more room, get a bit more real estate, as people say. So so for this one, let's do this in a different color. We'll do it in green. So this one we've got row 4 is going to go to row 4 minus C over A again, because we want the A's to cancel when we multiply it by row 2, and then we'll be left with just C, so that'll be row 2 there, right? So row 4 minus C over A times row 2, and so let's just go ahead and plug that in, and we've got 0 minus C over A times 0, that's just going to be 0, and then we have C minus C over A times A, which is C minus C, which is 0, right? So then we got 0 minus 0 again, so that's 0, and then we've got D minus, so for the fourth element, we've got D minus C over A times by B, okay? So then we have here, we've got 1 minus C over A times 0, so that's just going to end up still remaining as 1. Alright, fantastic. Okay, so now we have our upper triangular matrix. So I'm just going to write that out, because we've got our new row 3 and our new row 4 here to write out. So let's just go ahead and put them in. So we have enough now to work out and solve for our 4 unknowns. So let's just crack on and do that. So for the first equation that we're going to solve for D dash, because that's the one with just that in the equation. So we have D minus CB over A, all multiplied by D dash, is equal to 1. Now, let's try and get this all over A, okay? So to do that, let's just multiply this D, both top and bottom, by A, and it'll just remain the same number. So that's DA, so that's going to be DA minus CB all over A, because there's the common denominator now, okay? So we can put that all over A, and that is going to be times by D dash equaling 1. So let's go and let's solve this then. So multiply by A, divide by DA minus CB, so we get that D dash is equal to A over, and I'm going to write it in this format just so that it rings a bell. AD minus BC. So that's exactly the same. So A over AD minus BC. There you go. We've got our first element of our inverse matrix. And I'm not going to dwell on it right now because I could just end up talking about it. So we'll just carry on. But notice this. Look. It's the determinant. Anyway, let's just carry on. Let's pretend I said nothing. Right? So we have D minus CB over A multiplied by C dash is equal to minus C over A. Okay, so once again, I'll just do the same thing. We've got AD minus BC all over A. C dash is equal to minus C over A. So, multiplying this out, we'll have, if we multiply by A first, then we'll have minus C divided by AD minus BC. So we'll get C dash is equal to minus C divided by AD minus BC. Fantastic news. Right, so that's our next element, okay? And there seems to be a theme here. So, it's great stuff. It's fantastic news. So let's move on to our next one, which is going to be A times B dash plus B times D dash. Okay? A times B dash plus B times D dash. Okay, and that is going to equal 0. Alright, so let us, instead of bringing in D dash just yet, let's rearrange things so that, you know, once we bring it in, it might slot into place. Alright, so we'll have, we know D dash, so let's just move everything across and divide by A. So we have B dash is equal to, so we've minus B D dash, so is equal to minus B times D dash all over A, because we divided by A, yeah? So, that's what we've got. Let's bring in D dash. So, when we bring in D dash, we have, so B dash is equal to minus B over A, and I'm going to write it like this, and then we've got times by A over AD minus BC. So the A's cancel, and we are left with minus B all over AD minus BC. Whoa, job done. Right, we've got our B dash. So the next one is going to be A dash. We want to find our A dash. So we have A times A dash plus B times C dash is equal to 1. Okay, so let's just rearrange everything and have it so that we've got everything ready for just A dash. So A dash is going to be equal to, so we've got a 1 on this side, remember, so we've got to minus BC dash over A. So 1 minus BC dash all over A. Okay. Now then, let's bring in C dash. That is going to equal 1 minus B times by, and C dash is going to be minus C all over AD minus BC all over A. Okay. Now, what we're going to do here is we're going to try and get so that we can cancel things out and move everything around. Let's try and get everything on top under AD minus BC. So this 1 over here, that is just going to be equal to, if we just make that equal to AD minus BC all over AD minus BC minus BC all over AD minus BC. And that is all over A. We're getting there, we are getting there. And that equals, so the BC's are going to cancel because we've got minus BC and then minus BC, so that'll be minus BC plus BC, and we are left with AD all over this on the denominator, in the numerator of everything. So we've got AD all over AD minus BC all over A. And so we know then from fractions how that's going to pan out is that if we were to have both of these in the denominator, or divide, or we're just dividing this fraction by a, then the a's cancel from the numerator here. So then that is just left with d all over ad minus bc. Yes! So there we go, we've got it. We have all of the elements of a 2 by 2 matrix inverse. And that's it. We've got them. So let me just write them out so that we can have a little bit of a parade at the end here. And so there we have it. We have our A dash, B dash, C dash, and D dash, all the elements of our inverse matrix. And if we were to have the equation A, B, C, D multiplied by A dash, B dash, C dash, D dash, by multiplying them both together, they will equal the identity matrix. And that is by definition what an inverse of a matrix is. So if A is just AB, CD, then therefore A to the minus 1, which is the inverse of A, is equal to 1 over the determinant of the 2 by 2 matrix, which is AD minus BC, D minus B minus C, A. And there we have it. That is the inverse of a 2 by 2 matrix, all worked out from the understanding of just looking to see whether it exists to post-multiply or pre-multiply or whatever you want to do to actually get the identity matrix right here. So that's what we just did there. That's fantastic. That's absolutely brilliant. So thanks very much for watching, guys. I really hope this video has given you some insight and understanding and backing as to why the inverse of a 2 by 2 matrix is what it is. If you liked the video, then do leave it a thumbs up, and remember to click that subscribe button and hit that bell icon to stay up to date with any new videos coming out from A Clever Chimp. Thanks very much for watching. I'll see you in the next video. Bye bye.